Hi, I'm Mikey, the master of the array. I don't use repeated aggregation during my multiplication. I use arrays as they are an incredibly useful tool that you can use in your classroom to teach your kids about multiplication. They're beautiful, they're everywhere in our world, but before we take a look at some examples, let's look at some board stuff, shall we? Alright, we'll look at this first diagram here. We've got 4 rows and 3 columns. We can express this as a 4 by 3 array. Moving on to the second example, we can see that we've got 5 rows and 4 columns. And we can express this, you guessed it, 5 times 4, or a 5 by 4 array. I love arrays so much, especially because you can show your students the relationship between equal grouping and arrays and multiplication. So if you draw your eyes to this third example here, you can see that I've got 2 groups of 5 blocks, which I have so easily transferred into a 5 by 2 array. And if you need some real world context, I'm currently smuggling a 1 by 2 array. Alright. So many reasons that I love arrays, most of which is the commutative property of multiplication. Now, drawing your eyes to the left-hand side of the board once more, we can see that this array has 6 rows and 3 columns. Now, when we express this as 6 by 3, we can identify these two numbers as factors. It equals 18, which is the product. Now, we'll look at this one, which we have 3 rows and 6 columns, and we'll express it as, mate, you guessed it, 3 by 6. And you know what's funny? That no matter the order of the factors, whether it's 6 by 3 or 3 by 6, the product is exactly the same. The order of factors does not matter, bro. Now, let's go take a look at one of my students, Billy, out in the real world.
I wonder how many lockers there are.
Why don't you count them, Billy?
I'll count them one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's so many. I wish there was a better way.
Billy seems to be struggling counting one by one. Let's see how he goes using arrays.
Heard something about arrays. I know that I have to do the columns first and then the rows. It has to be done like that or I won't get the right answer.
Are you sure about that, Billy?
Yeah, I'm sure I've heard something like that before.
That is a misconception. The commutative property of multiplication states that the order of factors does not affect the final product.
Oh, so 1, 2, 3, 4 lockers and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can either do 4 times 11 or 11 times 4. It's always 44. There are 44 lockers.
Congratulations, Billy.
Yay!